Okay. طيب, let's start. I will share my screen, and I will start. Okay, and I will start by going to AVR Studio 7 or AVR Studio 4. I have 7, I have 4, I have 5 on my computer. So I will start with AVR Studio 7. Okay, so in the AVR Studio, I'm going to start a new project. In this project, I'm going to say it's a GCC C executable project, and I'm going to call my project first program. You can see me, right? You can hear me?
Yes, doctor.
Okay, shukran, Ahmed. Okay, so then I'm going to choose my microcontroller. Now you can see here we have a lot of microcontrollers. So if we were in the university, usually we will go with the 80 mega 8515. If you remember this one, we used it in the lab, or the 80 mega 32. So I will go now with the 80 mega 32. Now in class, when we start talking about the microcontrollers, I will be explaining different microcontrollers, but they are all from the same family. Now these microcontrollers are all 8-bit. 32 means 32 means the cache size, the size of the memory, okay? Not the number of bits for that microcontroller. كلياتهم 8-bit microcontrollers. Even when I installed the AVR Studio, there was an option whether I want to install the 8-bit or the 16-bit or the 32-bit. I only choose the 8-bit microcontrollers. So I press OK, and then we will start doing our program. So our program, if you remember in C++, this is our documentation. This is the name, and the documentation is started by itself. So hashtag include avr/input/output.hex, then hashtag include. I will include the util, okay, slash delay dot h. Okay, so I will choose it. So this will allow us to have the delay in our program. If you want to have a delay in your program, you can use this. Then hashtag include AVR slash interrupt, if we are going to use interrupts. Next step is to write my program. Now, if you recall in microcontrollers in the last semester, last year, the program has two parts. The first part was the initialization of the ports, whether our ports are inputs or outputs, okay? Then, and initialization of our variables. Then we have a while one loop, which is an infinite loop that will keep repeating itself. So I will start here by saying I have an unsigned character. Unsigned. Anyone knows why I'm using an unsigned character? Unsigned character. Okay. Why I'm using unsigned character? Now, the unsigned character is basically 8 bits, and our microcontroller is 8 bits. We want our variable to have a size of 8 bits. Okay, so unsigned character. بعدين we will say that port A, DDR-A, okay? Remember, data direction register A. We talked about this in the microcontrollers last year. Data direction register A is equal to 0x00. Sorry, 0x00. This means that the microcontroller is 8 bits and all the 8 bits are used for input. So this is input. Then DDR B. I will use B. Okay. By the way, I'm copying from the lab manual. I'm not inventing the code now. 0x 0FF. Remember, 0x is used for what? Why 0x? ليش 0x? For hexadecimal, yes. 0x is used for hexadecimal. So this is an output. Now, last semester we did this and we went to the lab and we did it on the STK 500 kit. Now we don't have the option of the STK 500 kit. So there are still some options. We can create our programmers, but I don't have enough actually. But let's see how things will go. We may do it by hardware, but let's start with the software. Now, inside the while one, I will write my program. My program will do what? Will take PN, sorry, I tab I is equal to that I small I is equal to PNA semicolon. So I'm reading the values from port A and then I am sending the output to port B. So port B is equal to I. Okay, so I'm reading whatever is at the input, I'm sending it to my output. Okay, then of course we have the return one. I think something is wrong when right. Okay, so these two are deleted here. While one we need a bracket here, and we need to close the bracket over here. هيك صح. Okay. So then I'm going to save it and I'm going to run it. Now, if it runs and everything is fine, we will get here the message that our build is successful. Okay, our build is successful and we have no errors. Okay, 0 errors, 1 warning. That's fine. Now, where did I store my program? I need to check where I stored my program. First program. Properties. Okay, maybe in my documents. Okay, that was one mistake. I should have done what select all, copy file. I will make like save as where it is saved. It is saved in first pro. Okay, it's saved here. See the directory. It is 7. It is documents at AVR Studio. So if I go to my documents, okay, I will go to my documents at AVR Studio 7, and it's called first program here. Now here, what we are searching for is our hex file, this one. Okay, we are going to need our hex file. I will leave it here. Then I will go and start Proteus. Now in Proteus, I'm going to start a new project. I will call this project first circuit. Next, I will keep this one as template as default. Next, I will not need a PCB. PCB stands for printed circuit board. Okay, PCB stands for printed circuit board. Next, I will create a framework. So which family I'm using? I'm using the AVR. Which microcontroller I have used? I used the 80 Mega 32. Okay. Which compiler I'm going to use? I'm going to choose WinAVR. Okay. I'm going to choose WinAVR as my compiler. Now, if you recall, I asked you to install. Sorry, I will go to the Teams here. If you recall, I asked you when installing the files here. Shall I close? Okay. Here in files, there is something called WinAVR. You need to install WinAVR. Once you install WinAVR, you are going to have it here on your C drive as WinAVR. Now, this is all. We will not open the program, but when it comes to Proteus, we are going to say that our compiler will be WinAVR. Okay. If you choose the other Proteus AVR ASM, it will not work. So we need to choose WinAVR as our compiler. Next, then I'm going to say finish. Now, once we create it, we will have our microcontroller already over here and ready to be used. And you can see that our microcontroller has the VCC and ground and everything is ready. Now I have configured port A as my input and configured port B over here as my output. So the first step is to add the hex file to the microcontroller. So I will double click on the microcontroller and then I will click on the open file here. I will choose from my documents, we set the AVR Studio. Where is it? Okay, 7, first program, debug, and I will choose the hex file, this one. Okay, so I will open and I will say, okay, now my microcontroller has the program. The next step is to create the outputs. So for my outputs, I'm going to need LED. So devices, I'm going to say I want a green LED. So I have a green LED active, this one. I will choose this green LED here. Okay, and then I will close it. So I will put one, this is a matrix, sorry, I chose the wrong one. Okay, so I'm going to say again, green LED. Okay. Okay, so I have here my green LED. Of course, I need terminals. I need a ground. So I will connect one ground for the circuit. I will connect the ground here and I will connect the LED to port number 1. Okay, I can replicate this. I can select these parts and say copy, paste. Copy to clipboard, and then I will flip here, paste from clipboard, and I will click like this. I will put it here, then I will connect it, then I will connect it to pin number 2. The next step, I want to create switches for the inputs on port number A. So I'm going to go again once more to my components, and I'm going to say I want a switch. Okay, the switch, first of all, this will not work because this one, when you open it, it's open circuit. we don't want to open. We want either high or low. So we want a double throw switch. Okay, we want a double throw switch, which is okay. Which is this one. Okay, so this one is a double throw switch. The idea about this switch I will tell you now. Now, if I click this switch here, now if it's high, it will go for VCC. If it's low, it will go for ground. So I need to rotate it once more. Okay, the port number A of this pin will go here. Okay, this is not connected. To test whether a connection is right or wrong, click on the object and try to move it. If it moves with the wire, then everything is fine. طيب, the second part will be connected to ground. Okay, and one of the parts will be connected here to VCC. Okay, so I can do another switch for another input here. And again, I will rotate it 180 degrees, it's faster. Then I will take the second port of port A, connect it here, and the ground can be connected to the ground, and the VCC can be connected here to the VCC. Okay. Double check. We have the file here. We have the connections. Then I will try to run my code. Okay, no errors. Okay, so I want to explain a few things first. You can see that red means high, blue means low. So since the switch is connected to blue, it is showing blue over here, and it is showing blue over here. These two ports are having output as blue since I put blue on here. If I click here, I will have red, but I need to have the red also over here. I will have to double check what's the problem. I will check it now. The same applies for this port over here. Now you can see that the switches are working fine. VCC is working fine. The problem is with the output over here. Now let's start our double checking. The first mistake here is having two grounds. I will delete this ground and I will connect the circuit to the same ground. I will check again, still no output. Then double check on the code itself. Okay, double check on the code itself. Again, nothing. So I will go back to the AVR Studio and check my code. In the AVR Studio, let me check my options also. Okay, so another double checking that I can do, which is I will go back to my code. I will select all the code, copy, and then I will close it. I will try again. The circuit is fine. Okay, my circuit is fine. So I will double check by using another AVR Studio, and then I can see what's the problem. See, debugging the programs takes some time because the code looks fine, the circuit is fine, but I'm not sure what's going wrong. So we start a new project. We have nothing, no problem. We want an AVR C++, which is an executable library, and then okay, executable library. Then I will call it as program elec 4000. It's stored here in AVR Studio 5.1. Okay, and then I will choose the 80 mega 32. Okay, so and then I will select all, Control V, should be saved, no problem. Then I will compile it, and here cancel. What happened? Okay, let me double check if okay, so crashed, the Proteus crashed. Open it, yes. Okay, so now here I will choose another file which is from my library. I will go to my documents. Sorry, this is the downloads, the documents. I will go to 80 mega 5.1 and I will go to electro program, debug, X file. Okay, then I will run. See here, now it's working. Now look, when I do close, it closes. When I do open, it will open. So this is what I want you to do first. I want you to go through these steps, okay, to make sure that your programs are running fine. Okay, the only way to make sure that the programs are running fine is through checking these connections. You can see here my connections. Okay, if I close switch 1, lid 1 will be off. If I close switch 2, lid 2 will be off. Do you have any questions? Of course, look, what the message, I will show you something. My screen is still shared. Sometimes you get here a message, unknown error. If you press OK on the unknown error, then you are going to close your Proteus. Just ignore the error, okay? Ignore the Proteus error. This is the first step because later on we are going to connect more things to our microcontroller, okay? So this is basically our first step where we are going to start doing our programs. Do you have any questions?
Doctor,
نعم.
the files should be same names in both program?
No. You just want to copy the hex file. You just need to copy the hex file, okay? Remember, after you execute the program, if I go here back to my documents, you can see that here I have many programs. If this is the program, I need to go to the hex file. Inside debug, there is .hex. Now, searching for it here is a little bit difficult. But see this error, just forget the error, okay? I double click here. When you click here and you go again to documents, you will find the AVR Studio. Choose it, choose your program. You just keep clicking until you see the .hex file, okay? And then you click OK. Okay, then you run, then everything should be fine. Any other questions? طيب Since you don't have questions, please try to do these steps that I have done. And if you have errors, please let me know. Okay? If you have errors, please let me know so that we can manage to fix these errors. Okay? I will upload this video to the channel on Microsoft Teams so that you can refer to it later on if you want to go through the steps again. Any other questions before I go? Okay, thank you.